Hey everyone, I am back again for another episode of Advent of Code here. I'm going to be working on days 5 and if all goes well, maybe 6 and 7. Um, and if all doesn't go well, maybe I'll just get stuck somewhere and grind my wheels for a little bit. Today I'm on a different keyboard. I have a Microsoft Sculpt keyboard because I was getting pain in my wrists again, which generally just happens if I type on normal keyboards quite a lot. It's just a sign I've been doing a lot of typing. I've been working on some blog posts and stuff. Usually goes away if I really just switch to any other different keyboard for a little bit. Roxy's here. She's just on the couch. You might hear her jingling or barking at who knows what. But yeah, let's get down to puzzle 5. Let me just, there we go. I can see chat. You're starting to sweat as the ship makes its way towards Mercury. The elves suggest that you get the air conditioner working by upgrading your ship computer to support the Thermal Environment Supervision Terminal. The Thermal Environment Supervision Terminal, TEST, starts by running a diagnostic program, our puzzle input. The test diagnostic program will run on your existing Encode computer after a few modifications. Okay, so we might be able to just require the day 2 or whatever that was. First, you'll need to add 2 new instructions. Opcode 3 takes a single integer as input and saves it to the position given by its only parameter. For example, the instruction 350 would take an input value and store it at address 50. As input, takes a single integer as input and saves it to the position given by its only parameter. I don't follow, but I'll have to look at it. Opcode 4 outputs the value of its only parameter. For example, the instruction 450 would output the value at address 50. Programs that use these instructions will come with documentation that explains what should be connected. Oh, okay, I see. What should be connected to the input and output. The program 304099 outputs whatever it gets as input, then halts. 3040. Right, so it takes the input from the input stream, writes it to register or location 0, outputs whatever is on 0, and then halts. Okay, I follow that. Second, you'll need to add support for parameter modes. Each parameter of an instruction is handled based on its parameter mode. Right now, your ship computer already understands parameter mode 0, position mode, which causes the parameter to be interpreted as a position. If the parameter is 50, its value is the value stored at address 50 in memory. Until now, all parameters have been in position mode. Now your ship computer will also need to handle parameters in mode 1, immediate mode. In immediate mode, a parameter is interpreted as a value. If the parameter is 50, the value is simply 50. Parameter modes are stored in the same value. Parameter modes are stored in the same value as the instruction's opcode. The opcode is a 2-digit number based only on the one. The opcode is a 2-digit number based only on the 1s and 10s digit of the value. That is, the opcode is the rightmost 2 digits of the first value in an instruction. Parameter modes are single digits, 1 per parameter, read right to left from the opcode. The first parameter mode is in the hundreds digit, the second parameter mode is in the thousands digit. The third parameter mode is in the tens thousands digit, and so on. Any missing modes are 0. I'm not sure I understood that, but okay. For example, consider the program 1002, 4, 3, 4, 33. The first instruction, 1002, 4, 3, 4, is a multiply instruction. The rightmost 2 digits of the first value, 02, indicate opcode 2, multiplication. Yeah, I remember that. Then, going right to left, the parameter modes are 0, hundreds digit, 1, thousands digit. 0 and 1, going right to left. Oh, okay. So I read the additional digits as the modes of the additional parameters that make up the instruction. Okay, well, it's nice that they leave off the extra digits so that I don't have to, I don't know. Make sure they don't get parsed as octal. Um, okay, yeah. Yeah. Okay, yeah, we can do that. The instruction multiplies the first two parameters first, blah, blah, blah. It is important to remember that the instruction pointer should increase the number of values in the increase by the number of values in the instruction after the instruction finishes. Because of the new instructions, this amount is no longer always 4. Cool, yep. Integers can be negative. It's a valid program. Fine. Yes, that's acceptable. The test diagnostic program will start by requesting from the user the ID of the system to test by running an input instruction. Testing will start by requesting from the user the ID of the system to test by running an input instruction. Provide it 1, the ID for the ship's air conditioner unit. We'll then perform a series of diagnostic tests confirming that various parts of the encode computer, like parameter modes, function correctly. For each test, it will run an output instruction indicating how far the result of the test was from the expected value, where 0 means the test was successful. Non-zero outputs mean that a function is not working correctly. Check the instructions that were run before the output instruction to see which one failed. Finally, the program will output a diagnostic code and immediately halt. This final output isn't an error. An output followed immediately by a halt means the program finished. If all outputs were 0 except the diagnostic code, the diagnostic program ran successfully. After providing 1 to the only input instruction and passing all the tests, what diagnostic code does the program produce? Ooh, okay. We've got a bunch of changes we have to make to day whatever that was. So guess we'll just start by we will start by correctly attaching to the right TMUX session without revealing without revealing what my other TMUX sessions are called. Cool. I should have set this up previously. And we are on day 5, part 1. There we go. Cool. So we need, now was it 2019-2? Was 2, well, yeah, it was 2019-2. Puzzle was the one that was the opcode computer. And we can probably just copy that in, you know? Copy pasting is best practices in Advent of Code. Puzzle B. So that's that. And we need the input. We need the input of the right problem. 2025 input. Yeah, there we go. All right. Now, just turn my brightness up here so I can see a little better. Now, bad instruction 3. Perfect. That's an expected thing. Okay. So what should we do first? The things we need to do are start advancing the current instruction or the position, the program counter, by the correct number of whatever we call them, locations. We know That's a thing. That's a thing. So we now need to implement 3. And, oh god, that's bright though. So 3 takes a single, or let's do 3 first, and then like try to get this program running, and then we'll fix the parameter modes. So opcode 3 takes a single integer as input and saves it to the position given by its only parameter. Oh, it's going to be kind of ugly. But it's going to do position op1 equals input. Sorry, I guess program input, I guess maybe. Dot pop. And program input is supposed to be a 1, right? So we'll just have an array with a 1 in it, and that'll be our input. And that looks like an instruction, and then we need to advance it by only 2 this time, because it's the instruction itself and and the single operand. So bad instruction 0. That's probably because this didn't do what it was supposed to do. Oh, let's look at the input. What does it initially do? Input 5 this year. So it's going to write 1 to position 225. Then it's going to do, okay, so probably that third instruction, the one that starts with 1100, is a problem. 1, 2, 3, 4. I don't know. It's so hard to read these. So like that's an instruction. 1 takes 3. 1 takes 3. So this is going to try to write something to position 6, which is this one. So that explains what's going on. Does it? Then who knows what's going on later. I don't know. It's hard to wrap my head around, so let's just move on to implementing 4. See if that gets us, because the 4 isn't there. Outputs the value of its only parameter. For example, instruction 450 would output the value at address 50. Okay, so then this is also going to be a 2, and we want to just output something like that. That's right. That still doesn't help us here. I'm going to guess this is because of the modes. Now, getting them as, I mean, kind of want to refactor this, but I also kind of don't want to spend more time on it than I need to. Okay. Come on, chat. Is there anyone in there helping me? Oh, this isn't showing. I got 1 viewer. If that's just me. Hello, viewer, if it's not just me. What? So probably want to send in these methods have access to everything they need to determine their own op, or whatever we call them, parameter mode. So let's create a parameter mode. And current instruction dot digits dot reverse. So that's not the whole implementation of that. We're going to say if op1, so if parameter mode 1 equals 0, then we do the existing behavior. Then we do this. And otherwise, we know if it's, let's reverse it, because we know if there's not a digit, then it's a leading one, and we're assuming 0 in that situation. So then our methods are all going to look something like this. And we'll just do the same thing for, so there are two. We should have just parameterized these methods, but whatever. So we'll place those ones with 2s, except for the second one on the line, which is just kind of convenient. And we'll do those with 3s, and that looks kind of like what we want. So we can even, I guess it doesn't really matter. So current instruction.digits.reverse, 0 and 1. So the first operand needs to be 3, so it's n plus 2, or 0. Looks vaguely correct, but it's broken our machine up here, because this is now supposed to say op1. Don't care about the calls to op3 currently. And this is just, that might just be fine. Oh, right, bad instruction 1100. Well, that's something different anyway. Right. So actual instruction equals something current instruction. So we need only the 10s. Is that just like %100? Is that, am I losing my mind? So 1099%, 100, 99. These are all going to be 99, right? Let's be like, yeah. Looks like it works. Bad instruction 1100 still, so that is interesting. We shouldn't be getting 1100 because this is supposed to store some value in 225, and then this is supposed to So the 1 is supposed to add operand 1 and 2, 1 and 2, and place it into 6. So 225 plus 6 is 231, and 231 into 6 is 1, 2, 6. Isn't it overwriting itself? Oh no, 0, 1, 2, 3, 6. So that's going to be like 1400 or something. Interesting. Why is that not working? Why is this not working? Let's use our good friend Pi. So actual instruction on the first instruction is going to be 3, correct. 3 is grab program input. Love it, looks good to me. Next actual instruction is a 2. Current instruction is 2. Just double checking here. Why is it 2? What is going on? 3, 12, 2, 20. Let's just try this over again. I want to examine my input and make sure it looks right. Yes, bad instruction. It's the same bad instruction. So, put no instructions have been executed. 3, 12, 2, 225. 3, 12. That's wrong. What's going on? It's the input. What have I missed? What? This is my input, right? 3. How am I? Oh boy. I forgot. That's pretty funny. Okay, well, yeah, don't show. So what I forgot about is that when we run programs in this, we were using the old thing that overwrote some of the values. So, see if this gets us a little further. It does not. That's kind of upsetting, but at least we have the right input now. So, actual instruction is, see, not totally used to this keyboard yet. Okay, and then we can double check that input 225 has been set to, oh, it didn't work. Isn't that what it's supposed to do? Let's take the input and write the thing to it. 3 up 1 is 225. Well, I guess we'll start there. Okay. Get into here. Op 1 is 0. No, it's not. Position 0. Parameter mode 1 is 0. Why is that true? What have I done wrong? Current digits, so current instruction, good. Digits, oh wait, no, this is right. Current instruction dot digits dot reverse 3 n plus 2. 1 plus 2 is 3. 4, 0. Yeah, cool. Why is op1 0 though? $1. So parameter mode. Parameter mode 1 is not 0. So we're looking for input. Oh, but this instruction doesn't have parameter modes, I guess. Or I misunderstood the parameter modes. Kind of hoping it's that one. Parameter modes. Already instance parameter mode 0. Yeah, but these instructions. Mode equals parameter mode 1. So this is going to be a hack, and I'm okay with it. So this will allow me to short circuit the desired parameter mode for each one of these. Cool. So that shouldn't change the behavior of the system as it stands currently. And I can specify parameter mode 0 in this case. Same with this one. Okay. Still doesn't work. So that's cool. Wow. But at least I suspect it's maybe doing the right thing. So we'll do that, and we'll do that, and we'll just examine it. So actual instruction is 3, current instruction is also 3. Input is going to give us back a 1, but I won't pop it yet. Op1 0 is still 0. Do I have this backwards? Oh, what's going on here? Op1. Oh, I do have it backwards. I definitely meant this. Definitely meant that. Though this could just be cool. Programming is hard, cool. And input 225 should now be a 1. Yes. Doesn't change that something else is broken, but that is doing what it's expected to do. So our next value is a 1. All right. Let's see if it's doing what it's supposed to do. Here, op1 is 1. Op2 is 1100. That is incorrect, unless I've missed something. Current instruction is 1. Position is 2. Yes. Op1 is, op1 is the value add thing. So op1 is 225. And the value at 225 is the one that we picked up. Oh, God, this is fun. Here we go. So that's that. The value at 6 is the number 6. Oh, no, it's 1100. Value at 6 is 1100. So we're adding those together. We're putting them to 6. Cool. So that should op 3. Nope. That's the problem here. I see. All of mine are backwards. So whenever I am writing, I need to specify that we need mode 1. We are doing the work here. Okay. Undefined method plus 4 nil class. Well, that's a more exciting issue. That's on line 19. Which one of these ends up nil? 3, 1 could be nil. No, don't care if it's nil. Care about up 1 and up 2. Not there. 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 Uh-oh. Oh, there it was. I hit the easy way. If op 1, op 2, any question mark. No. Boom. 1 is nil. Set I position. Plus 1. So the actual value here is 944. So that could be right. We are expecting there to be negative values in this. Current instruction is a 101. So the first instruction should be interpreted as a literal value, which means that op1 should be right, but it's not. So we got our parameter mode. Parameter mode 1. Parameter mode 1 is 0. 2 is 0. 3 is 0. 0 is 1. So I presumably added too much. Parameter mode probably supposed to be plus 1, really? Yes. Because it's the starts, yeah, I got it. Off by 1 error. Cool. Huh. Well, I think our program is supposed to output all zeros. So that's not working, but we got a solution. So that's interesting. So what do we say? Finally, the final output disk immediately halt. The final output isn't an error, it's an output followed by an immediate halt means the program finished. If all outputs are 0, except the diagnostic code. Diagnostic program, well, that it didn't, so that's not the right answer. Oh, it's outputting how many we're off by. Well, that's funny, right? Is that what we're supposed to be doing? But final solution 3. Well, that's okay. Let's take a little think about the rules and see what we had. A few things to do. We've implemented 3. We've implemented opcode 4. We've implemented parameter modes. Immediate mode. Put instruction. How far the result of the test. So we're just gonna blow up on the first one. I don't know. It's not like don't realistically think I'm gonna manually debug this code, the actual byte code or integer code. Assertion failed if output does not equal 0. I'm binding that premise, so that's that. Okay. So we get pretty position. Position 10. Okay. So 1, 2, oh, sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4. And it says output the contents is 0. The contents is 0. Oh no, it's saying output. It's saying the output, the literal, at 0. So 4 doesn't follow the rules that I thought it did. So output does not equal that. Still failed. Interesting. Position 10, 1, 3. Parameter mode 1 is 4. That's interesting. Definitely wrong. So I should have just done it there. So parameter 1 is parameter mode, so we can look at what it is. And current instruction dot digits is 401. Oh, it's already reversed. It's already reversed? Huh. Well, there you go. Neat. So the digits method provides the digits of a number from smallest to biggest already, so we don't need to reverse it. I think that's still all good. Position failed at position 220. What? Assertion failed. Oh, yeah, so we don't normally want to raise there. Cool. All right. It appears as though our machine. Sorry, I'm used to using Alacrity, which has different bindings. All right. And And gold star. Okay, it was a little hacky, but we got there. 2019, day 5, part 1. Boom. Complete. Let's do part 2. Whoops. Part 2. The air conditioner comes online. Its cold air feels good for a while, but test alarms start to go off. Since the air conditioner can't vent its heat anywhere but back into the spacecraft, it's actually making the air inside the ship warmer. Instead, you'll need to use the test to extend the thermal radiators. Fortunately, the diagnostic program, your puzzle's input, is already equipped for this. Unfortunately, your encode computer is not. The computer is only missing a few opcodes. 5 is jump if true. If the first parameter is non-zero, it sets the instruction pointer to the value from the second parameter. Otherwise, it does nothing. Opcode 6 is jump if false, which I assume does the reverse. Opcode 7 is less than. If the first parameter is less than the second parameter, it stores 1 in the position given by the third parameter. Otherwise, it stores 0. Opcode 8 is equals. If the first parameter is equal to the second parameter, it stores 1 in the position given by the third parameter. Otherwise, it stores 0. Like all instructions, these instructions need to support parameter modes as described above. Normally, after the instruction is finished, the instruction pointer increases by the number of values in that instruction. However, if the instruction modifies the instruction pointer, that value is used and the instruction pointer is not automatically increased. That makes sense. For example, there are several programs that take one input, compare it to the value 8, and then produce an output. Okay, cool. Yeah, those, I believe that those are what those do. Here are some jump tests that take an input, then output 0 if the input was 0, or 1 if the input was non-zero. I could use these to write my own diagnostics. On a larger example, this time the test diagnostic runs its input instruction to get the ID of the system to test, provided 5. The ID of the ship's thermal radiator controller. This diagnostic test suite only outputs one number, the diagnostic code. All right, so switch back to iTerm. There we go. We can run that, gives us 0. That's funny. Just gonna run anyway. We are going to redefine the program input. Program input doesn't really matter, but we're putting the 5 in there, and so then this thing's gonna blow up because it doesn't understand 5s, and we should be able to expand it to support 5 and the rest of these without too much trouble. So without breaking the previous one. So let's go through back to our docs for our new ones. We've got a jump if true. The first parameter is non-zero. It sets the instruction pointer to the value of the second parameter. So we say if op1 does not equal 0, and if the first parameter is non-zero, sets the instruction pointer to the value of the second parameter. At position equals op2, else at position. So this takes 2 parameters, so we're going to increase it by 3. Cool. And then we might as well implement. I'll implement 6, which is jump if false. Jump if false, and that is the same thing except for if op1 is 0. Sure, we'll run that to make sure it runs. It's going to hit bad instruction. 25 isn't an instruction, but that could be just the program misbehaving for some reason. Nothing I should do after this should. That's suspect. That's very suspect, but we'll come back to it. Let's do 7 and 8, and then we'll figure out what's going on there. Sorry, 7 and 8, not 6 and 7. Let's Still getting used to the ergonomic keyboard again. All right. Just checking to see if I have any viewers, but looks like I don't. If 7 is less than, if the first parameter is less than the second parameter, it stores 1 in the position by the third parameter. So this is if op1 is less than op2, else. And this is, we're going to say input op3 1 equals the result of this, and we might as well just write this as one line, I think is right, and then we add position plus equals 4, and the same is this one, and that's equals. Cool. Interesting. Still bad instruction 225. Position is 9. What? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 225, yeah. This is a 5. It's going to do, let's just, I think the first, so position, yeah, op1, not a 0. So input, if we look at the input, we can see that I was not thinking clearly about how this worked. So we're at position 6. Input stream 1, 2, 3, 4, sorry, 0, 1, 2, 3, 4, 5, 6, 5, and 5 is if operand equals 0. Did I do that backwards? 5 is jump if true. Yeah. How did I mess that up? Did I copy paste and edit the wrong one? Weird. Huh. Well, we can ignore the solution. That's a product of how things used to work. And boom. Okay. That was a little annoying, but we got there. 2019, day 5, part 2. Cool. Well, thanks for watching me do Advent of Code 2019, day 5.